Nvidia just revealed something that flips conventional wisdom on its head. Their new Rubin data center design runs intentionally hot to use dramatically less water. We are talking about systems pushing temperatures so high they'd melt a consumer laptop, all to slash water consumption by massive amounts. The insight here is wild. In a world where AI companies are drowning data centers with water to keep chips cool, Nvidia engineered Rubin to operate at temperatures around 45 degrees Celsius, that's 113 Fahrenheit, hot enough to make most of us uncomfortable just standing near it. But here's where the genius kicks in. By tolerating that heat, Nvidia eliminates the need for the massive water cooling loops that currently drown every major AI facility on the planet. Traditional data centers pour millions of gallons of water every single day just to dissipate the heat from their chips. It's become a sustainability crisis, and Nvidia looked at that problem and asked a different question. What if we just let it get hot instead? The company claims Rubin can cut water usage by up to 80% compared to traditional liquid-cooled systems, which is staggering when you consider the scale of modern AI farms. This isn't just an engineering feat. It's potentially one of the most important sustainability breakthroughs in AI hardware in years. And here's what the headlines aren't telling you. If Rubin works as claimed, it could reshape how every company on Earth builds their data centers. To understand why Nvidia's approach is so radical, you need to grasp the absolute scale of water consumption at modern data centers. Right now, a single large AI training run can consume as much water as a small town uses in a month. We are talking about hundreds of thousands of gallons per day at facilities run by Google, Meta, and Microsoft. The reason is physics, the sheer power density of modern GPUs. A single Nvidia H100 GPU consumes around 700 watts. Now multiply that by thousands of GPUs running simultaneously in a data center, and you're looking at tens of megawatts of electrical power all converting into heat. That heat has to go somewhere, and for decades the solution's been the same: cool it down with water. Traditional water-cooled systems pump gallons and gallons of water through channels, absorbing the heat, and then either cooling that water back down using enormous chillers, which require even more electricity and water, or dumping it back into the environment. The problem cascaded in 2023 and 2024 as AI exploded. Data center water usage became so severe that communities started pushing back. There were headlines about Google using 1 billion gallons of water in Texas, while the state faced drought conditions. Meta faced similar criticism. Amazon's data centers raised concerns in cities across the country. The industry realized this wasn't sustainable, not environmentally, not politically, and eventually not even economically. Here's how Rubin fundamentally changes the game. Instead of liquid cooling that tries to keep everything cold, Rubin uses direct-to-chip liquid cooling at much higher temperatures. The key innovation is accepting 45 degrees Celsius water directly onto the GPU die. That's about 113 Fahrenheit. Normal PC water cooling maxes out around 30 degrees Celsius to stay safe. Rubin just doesn't care about staying cold. The chips are engineered to tolerate the heat. This matters because hot water is way easier to manage than cold water. Think of it this way: if you want tap water, you just need pressure. If you want ice water, you need a refrigerator. Rubin operates at hot tap water temperature, so you skip the expensive refrigerator step entirely. Instead of massive chillers running 24/7 to cool water back down, Rubin's liquid pumps to a simple cooling tower, or even into the environment directly in some cases. That eliminates the energy-intensive chilling step, and Nvidia says this cuts the data center's cooling-related power consumption dramatically. The second innovation is that Rubin's chips are selected specifically to handle these temperatures reliably. They're not using silicon that happen to tolerate heat. They are physically testing and selecting silicon proven to run stable at higher temperatures. It's like finding binned overclocking chips, except the goal is reliability at heat rather than speed at cold. This means fewer failures and longer lifespan in actual deployment. The numbers Nvidia claims for Rubin are genuinely staggering. The company states that Rubin can reduce water usage by up to 80% compared to traditional liquid-cooled systems. Let's put that in context. If a conventional large data center uses 1 million gallons of water per day for cooling, Rubin could cut that down to 200,000 gallons. That's 800,000 gallons saved daily, enough drinking water for a city of 20,000 people for a full day. Scaled across all the new data centers being built right now, that's a transformative number. But water isn't the only metric that matters. Nvidia also claims Rubin reduces the power consumed by cooling infrastructure, the pumps, chillers, and fans, by up to 40%. Remember, cooling infrastructure at a modern data center uses about 30 to 40% of total facility power consumption. If Rubin cuts that by 40%, you're looking at a 12 to 16% reduction in total data center power consumption. That translates directly to lower electricity costs and lower carbon emissions. For a company running hundreds of data centers globally, that's potentially billions of dollars in savings and millions of tons of CO2 avoided annually. The heat trade-off is real. Chips running at 45 degrees instead of 35 degrees do have slightly shorter theoretical lifespans in some scenarios. But Nvidia's engineering focused on binning silicon that handles those temperatures reliably, so the practical impact should be minimal. How does Rubin stack up against what everyone else is doing right now? Most major data center operators, Google, Meta, Microsoft, Amazon, have invested heavily in traditional liquid cooling systems over the past few years. These systems pump cooler liquid through the data center, absorbing heat as it moves across GPUs, then route that heated liquid to massive chillers that cool it back down. It's effective, but expensive. A single chiller for a large data center can cost millions of dollars and consume megawatts of electricity constantly. Some companies have experimented with immersion cooling, literally dunking components in coolant oil, which is even more water efficient but introduces complexity and cost. Then there's Nvidia's Rubin approach. Accept the heat, engineer the silicon to tolerate it, and simplify the cooling chain. It's radically different from the industry standard. The comparison point that matters most, efficiency per watt. Rubin delivers more computing power per unit of electricity consumed in the cooling system than alternatives. That's why the 40% reduction in cooling power is so significant. It's not just about water anymore, it's about total operational efficiency. Competitors like AMD and Intel are watching closely, but they haven't announced similar designs yet. Google and Meta are exploring alternatives, but nothing with Rubin's claimed efficiency gains. The real question is whether the industry adopts Rubin's philosophy or develops their own high-temperature approaches. If Rubin works as advertised, the implications ripple across three major dimensions: sustainability, economics, and global competition. On sustainability, AI data centers are projected to consume 3.5% of global electricity by 2030. Water consumption is becoming the second crisis. As droughts intensify in Texas, Arizona, and California, where many data centers operate, water access will become a geopolitical constraint. Rubin could unlock data center growth in water-stressed regions that would otherwise face opposition. Economically, whoever cracks ultra-efficient cooling gets a massive advantage. If major cloud providers, Google, Meta, Amazon, Microsoft, can drop their cooling power costs by 40%, that's enormous margin improvement and changes competitive dynamics. Geopolitically, data center efficiency becomes strategic. China's data center costs would drop dramatically with Rubin. The United States has pushed for advanced chip restrictions, but efficiency innovations are harder to regulate than raw capabilities. Whichever region deploys efficient data centers first gains an economic edge in AI development and services. The final implication: expect a cascade of data center redesigns. If Rubin proves reliable over 5 years, every major operator will retrofit or rebuild. That's billions in infrastructure decisions hinging on whether this technology holds up long-term. Here's how Rubin actually gets deployed in a real data center, the practical steps that operators need to understand. First, the liquid cooling loop itself. Water enters the data center at around 45 degrees Celsius, flows directly onto the GPU dies through specially designed microfluidic channels, absorbs the heat from the chips, and then exits at maybe 55 degrees. That heated water doesn't go to an expensive chiller. Instead, it routes to a cooling tower, where fans spray it and let evaporative cooling bring the temperature back down. In warm climates, even that might be unnecessary in winter months. Second, the power distribution changes. Because cooling consumes so much less electricity, the data center's electrical infrastructure can be smaller and more efficient. Operators don't need as many massive UPS batteries or generator capacity dedicated to cooling systems. Third, monitoring and control. Rubin chips come with temperature sensors, and the system automatically adjusts liquid flow rates to maintain performance. If a chip gets too hot, the system backs off compute slightly to keep it stable. It's dynamic thermal management at scale. Fourth, thermal design of the building itself, with hot water exiting the system. Data centers can potentially use waste heat for other purposes, heating buildings, warming water for other industrial processes. Some forward-thinking designs are already exploring this. Here's what this means for you watching at home. If Rubin succeeds, it reshapes how artificial intelligence scales globally over the next decade. The companies that deploy this technology first get massive cost advantages and can undercut competitors. That flows through to cheaper AI services for everyone. ChatGPT, Gemini, Claude, all the tools you use become cheaper to run, which means better access for more people. It also means fewer environmental crises around data center water usage. Right now, communities are literally fighting with tech companies over water rights. Rubin could diffuse that tension in water-scarce regions. For the tech industry itself, this is a wake-up moment. Nvidia didn't invent this because they wanted to. They invented it because sustainability became non-negotiable. If one company can slash cooling power by 40%, every other company has to follow or fall behind. That competitive pressure drives innovation faster than regulation ever could. The bigger story, solving technological resource crises, becomes profitable when it saves money. When saving water also saves billions of dollars, everyone moves. Rubin proves that point. Watch for announcements from Google, Meta, and Amazon claiming their own high-temperature cooling breakthroughs over the next year. That's the real indicator of whether this becomes industry standard. Follow for daily AI news. We cover these inflection moments before they become headlines everywhere.